Imagine hearing the universe ripple. Sounds impossible, right? Well, that's exactly what scientists are doing with LIGO, the Laser Interferometer Gravitational Wave Observatory, and it's changing our understanding of the cosmos. Today, we'll dive into the science behind LIGO, exploring what gravitational waves are, how LIGO detects them, and why this discovery is so revolutionary. Get ready to explore the incredible technology that's letting us hear the universe. So, what are gravitational waves? Albert Einstein predicted them over a century ago as ripples in space-time, caused by accelerating massive objects. Think of dropping a pebble into a pond, the ripples spread outwards. Similarly, when black holes collide, or neutron stars spiral together, they create these gravitational waves that travel across the universe at the speed of light. These waves are incredibly faint, stretching and squeezing space by an almost imperceptible amount. LIGO's ingenious design is key to detecting these tiny distortions. It consists of two identical detectors, each shaped like a giant L, located thousands of kilometers apart in Louisiana and Washington state. Inside each arm, a laser beam is split and sent down a 4-kilometer-long tunnel, bouncing off mirrors at the end and then returning. If a gravitational wave passes through, it will slightly alter the length of the arms, causing a minuscule difference in the time it takes for the laser beams to return. This difference, smaller than the width of a proton, is what LIGO detects. The first direct detection of gravitational waves in 2015 was a monumental achievement, confirming Einstein's prediction and opening a new window onto the universe. Since then, LIGO has detected dozens of these events, including collisions of black holes and neutron stars. Interestingly, the neutron star collision in 2017 was also observed by telescopes across the electromagnetic spectrum, providing the first-ever multi-messenger astronomy observation combining gravitational wave data with light, radio waves, and more. This allows scientists to gain a much more complete picture of these cosmic events. LIGO's discoveries have fundamentally changed astrophysics, allowing us to study black holes and neutron stars in ways never before possible. It's proven Einstein's theory in an extraordinary way and opened up a whole new field of gravitational wave astronomy, promising even more groundbreaking discoveries in the future. We're truly listening to the universe in a completely new way. So that's the science of LIGO in a nutshell, detecting ripples in space-time to unlock the secrets of the cosmos. If you found this video enlightening, please give it a like and let us know what other science topics you'd like us to explore in the comments below. Don't forget to subscribe for more fascinating science explanations.